Hello everyone, I am Anisha. Welcome all of you to my channel, that is virtual classes. So today in this class we are going to start your chapter number 4, exploring magnets, okay, of your class 6 science curiosity. Okay, so we will start with the exploring magnets, and we have already completed the first 3 chapters. If you haven't watched those video, the link is given in the description. Kindly watch those as well, okay, and don't forget to like, share and subscribe my channel. So let us start. And yes, today the class explanation will be English. Okay, if you want to listen in Hindi explanation, I have already uploaded the video. You can again check the description for the link. All right, so now let us start and see. Here in this chapter we are going to learn about magnets, okay, and their properties. So let us start. So here a little girl is writing something, so let us find out what she is writing over here. Reshma, so her name is Reshma. Okay, Reshma lives in a coastal town of Kerala and is very fond of writing short stories. Her grandmother loves listening to her stories, so Reshma was writing a new story to share with her grandmother on her 60th birthday. So here Reshma, she lives in a coastal town of Kerala. Coastal means which is near this sea, isn't it, in the coastal areas. So, and she was very fond of writing short stories, and her grandmother loves to listen to her very much. Whatever she writes, her grandmother used to listen to her very happily. So she now decided that on her grandmother 60th birthday, she will write a short story, a new story. Okay, so let us see what story she is writing. The story was based on a ship carrying spices from Kerala for trade in the olden days. So her story, it was based on a ship. Okay, it was carrying, here in the picture you can see, okay, and it was carrying spices. See, spices are very much famous. Kerala's spices are very much famous, and they used to export to so many foreign countries as well, isn't it? So for in olden days also this happens. So in olden days trading usually takes place in ship. Okay, so Reshma was aware that in those days the sailors used stars to find direction at night. But in her story, a situation arose wherein the sailor got caught in a storm with an overcast sky and stars were not visible. So now Reshma was aware that in the olden days, okay, the sailors, how they used to find a direction? They used to find a direction by looking at the direction of the stars, especially the North Star. We used to call it as a pole star also, and it is the nearest star also, isn't it? So, but here in the story, okay, the story which she was writing, she was in a situation where these sailor they were caught in a very huge storm. Okay, and what happened with that? The sky was overcast with all clouds and the stars were not visible. So here Reshma was now worried. Okay, so what she will do? Because why? Because Reshma could not take her story forward, as she could not think of way for sailors to find direction. So now she was not able to keep her story forward, okay, write her story forward. Why? Because she don't know the other way, like if sailor caught in such a situation, how they used to find the direction. Okay, so now what happened? She then started searching it. Okay, so she searched for information on the internet and her school library. She learned that the travelers use a device known as magnetic compass for finding direction. So now she became curious and she started gathering information through the internet and by going to the school library, and she learned that travelers during those time, okay, in the olden days, they used to use a device known as magnetic compass, which the image is given here. Okay, and this is for finding direction. Okay, so now Reshma had seen pencil boxes and purses which had magnets to keep them closed. A writing board in her school also had a duster with a magnet, but she never looked at those carefully. She now became curious to learn more about magnets and magnetic compasses. So now Reshma, she have observed, she have seen magnet before also, isn't it? Like in the pencil box we have, in the purse we have. When we open the purse, there is a little magnetic metal. On one side there will be metal and another side there will be magnet, isn't it? When we close, they will attract each other and it get closed. So and in her school writing board also there was a duster which had a magnet, but she never looked at them very carefully. She never have observed them very carefully. Now she was on a writing of story and she learned that the traveler used a device known as magnetic compass. So now she became very curious to learn about more about this magnet and their magnetic compass. So along with Reshma, let us also learn about these magnets. I hope all of you are excited for your magnetic journey here. isn't it? So here some common items that have magnetic attachment to them are been given here, like these pins, isn't it, this dusters, this phone cover, which is a flip cover, which are very common. Even your parents might be carrying this type of phone, isn't it? Even I have this similar phone here. So they have this magnetic here, magnet is here, isn't it? So when we close this one, it get closed and it is not loose, isn't it? And here in this pencil box, the magnet used to be here, isn't it? When you close this one, it gets tight. And here in this drawer also, when we open the drawer, it gets open, and when we close the drawer, it gets closed and attached to it. Why? Because they have a magnet here, okay? And here, and similarly in the fridge door of the fridge also, okay, we have magnet. That is why it has been closely closed, okay, when we close it. So the magnet used by sailors in the olden days were based on naturally occurring magnets known as lodestones, which were discovered in ancient times. So the magnets which were being used by the sailor during the olden times, okay, it was a natural magnet. It was not artificially made. It was a natural magnet, and they were known as what? They were known as lodestones, okay, which were discovered, and these were discovered in the ancient times, okay, in the olden days. So later on, people find out that magnets could also be made from pieces of iron. So afterward, people started finding out that know that this magnet can also be made from pieces of iron. Nowadays we have magnet made of different materials. The magnet that you find in a school laboratory, those used in pencil boxes, stickers, toys, are all artificial magnets. The magnets can be of various shape, some of which are shown in the figure 4.2. So these magnets, okay, nowadays we started making magnets out of different materials, okay, and the magnets which you see in your school laboratory, or in the pencil box, or on your phone cover, or in the stickers, toys, these are all artificial magnet. Those are not natural magnet, okay. And these magnet, they have various shape, and some of the example they have given here, okay. Like the first one is the bar magnet, second one is the U-shaped magnet, and third one is the ring magnet. All right. So here our question is there: do magnets sticks to object made of certain materials only? So what do you think? Do magnets stick to object made of certain materials only? Have you any experience about this? Of course, yes. Okay, magnet sticks only to objects made of certain materials, because these materials are usually metals like iron, nickel and cobalt, which is given in your book. We'll learn about that, okay. And object from these materials are called magnetic materials, because they attract the magnet. And other materials like plastic, woods, glass, okay, they are they do not have any magnetic properties, so they are non-magnetic. So above we will learn about all this thing now, okay. So we'll have a activity here first, okay. So your next topic is magnetic and non-magnetic materials, okay. First we will go with the activity. So collect a few objects made of different materials, also a magnet, okay. Now you have to collect few objects which are made of different materials and also a magnet along with it. And now we will predict first, okay. Predict which of these objects will stick to the magnet. Write your prediction in table 4.1. And now hold a magnet in your hand and bring it near to the object one by one. Observe which of these objects stick to the magnet. So first, writing your observation, you start you predict first, okay, whether this object will whether this object will be sticking to the magnet or not. And after writing a prediction, now finally we'll be doing the experiment. That is, we'll observe it, isn't it? We'll hold the magnet in our hand and we'll bring all the objects one by one, and we'll see whether those objects are sticking or not in the magnets, okay. So now let us fill your table as well, okay, and see here some materials are been given. Again, out of this only I have written, I have fill up the table. You also you can fill up according to the experiment which you have done, okay. So record observation in the table 4.1. So here, so first we have the names of the object, okay, names of the object here, and then we have materials which the object is made up of, with these objects, okay, whether it is plastic, woods, glass, iron or any other, and attracted by the magnet, yes or no. First we'll write the prediction and after that our observation, okay. Like first two materials, first two objects have been given here, that is pencil and eraser. So pencil is made up of wood, okay, and our prediction will be no, and observation also comes to be correct, no, okay. And eraser, it is made up of rubber. Prediction no. See, rubber will not attract to the magnet, okay, that doesn't have any magnetic property with them. So observation will also be again no. Next I have taken scissors. That you see, scissors, it is made up of metal and plastic. You'll see the plastic side also and metal, and in some scissor again you'll see all the whole part, the whole scissor is made up of metals, isn't it? So we have different scissors, so I have written metal and plastic as well. So my prediction is yes and the observation is also Yes. And next we have a stapler, okay, and it is again made up of metal and plastic. So my prediction is yes, and the result is also yes, observation is also yes. Next we have a paper clip. We have a paper clip, isn't it, and it is made up of metal, okay, and our prediction is yes, and observation is also yes. Next we have a metal screw, iron, it is made up of iron, okay, and prediction is yes, and observation comes to be yes. That means it is attracting towards the magnet, okay, it is sticking to the magnet. Next we have plastic ruler, which you have your scale, isn't it? Along with pencil we use a scale also, so that is made up of plastic, so it will not be attracted, isn't it? So I predicted that it will not be attracted, and the observations also comes to be no, okay. Next we have a glass tumbler, and this glass tumbler is made up of glass, isn't it? And the prediction is no, and the answer is also no. The observation is also no. Next we have candle. Candles are made up of wax, isn't it? And the prediction is no, and the observation is also no. That means it will not be attracted to the magnet. The candle will not stick to the magnet, okay. Next we have key. Okay, so it is made up of metal, and the prediction is yes, and observation is also yes. So like this I have just taken a few items from the above given image. You can write the items which you have actually experienced with, okay, where you have actually done the experiment, and you can fill it on your own way also, okay. So was your prediction correct for all objects? In my case it was correct, isn't it? So in your case what it comes, you can write. So which material stuck to the magnet? What conclusion can you draw? So what conclusion can we draw? We can say that through this activity we find out that some of the objects were attracted to the magnet and stuck to it, while others were not, and this was our findings, isn't it? So here the thing which I have just told you before, the materials which are attracted towards a magnet are called what? Are called magnetic materials. Like the metal iron is a magnetic material, okay. Nickel and cobalt are other metals that are also magnetic, and some of their combinations with other metals are also attracted towards the magnet. Means if any other object is made use nickel or cobalt or iron, they will all be attracted towards the magnet, okay. And next what we have, the materials which are not attracted towards a magnet are called what? Non-magnetic materials. So I hope this is clear. Magnetic materials, those who are been attracted towards the magnet. Non-magnetic materials which are not attracted towards a magnet, okay. So which we have a question here, which material listed in table 4.1 were found to be non-magnetic? So according to my table, which were the items which come to be non-magnetic? See, pencil, eraser, plastic, plastic ruler, and glass tumbler and candle. These were the things which were non-magnetic, isn't it? So that will be the answer, okay. So here another question is here, do all parts of a magnet attracts magnetic material equally? So about this you will learn in your upcoming topic, that is poles of magnet. So let me give you the answer of this, okay. No, okay, not all parts of the magnetic will have magnetic materials equally. Why? Because the ends or the poles of the magnets, okay, especially the ends and the pole, which we used to say north pole and south pole, which is your next topic, okay, they are stronger parts, and they have stronger magnetic attraction with them, okay. So the end poles of the magnet are the strongest part, and they attract magnetic materials the most, and the middle part of the magnet has weaker magnet force compared to the pole. So now we will learn about that, okay. So we have again one experiment here, activity, and through experiment what happens, we learn better, okay. That is why there are so many activities in your book. Let us investigate. Spread some iron fillings, very small pieces of iron, on a sheet of paper, and then place a bar magnet over them. So we know what is a bar magnet, isn't it? We know the shape. So tape the paper and observe carefully what happens to the iron filling. So what will happen? See, the image is given here, okay, iron filling sticking to a bar magnet here. These are some of the small pieces of irons. So do you observe any special about the way they stick to the magnets? Yes, we observe it, and we'll explain it also, okay. Do the iron filling stick all over the magnets uniformly? No, okay, it doesn't stick all over the magnet uniformly. Why? Because we can see in the picture the poles here, this is the south pole and this is the north pole, they attract more iron pieces than the middle portion. Why? As I have told you the reason, the end of the poles, they are strongest part, okay, and they attack more magnetic materials the most, all right, and this is the weaker part. That is why only a few iron pieces are being attracted over them, okay. Or do the iron filings stick more at some places? So it stick on the poles, okay, more on those poles. We find that maximum iron filings stick near the ends of the magnet bar, here in the ends of the magnet bar, isn't it, as shown in the figure 4.4, while a very few iron filling stick at the remaining parts of the magnet. So what is the reason? I have already told you, isn't it? So if we repeat, so now she's thinking, okay, if you repeat this activity with magnets of other shapes, do we get the same result? Of course, yes, we'll get the same result, okay, because magnets of any shape, they contain poles, and on the pole section, the pole parts, they are more strongest, okay, the strongest part which attracts more magnetic material. So these ends of the magnets are called the two poles of the magnet, the north pole and the south pole, okay. I hope you have understood. Most of the iron filings stick to the poles of a magnet of any shape. So it is not possible to obtain, so here this we have question, can we find a magnet with a single pole? So it is not possible, okay, to obtain a magnet with a single pole. If a magnet is broken into smaller pieces, north and south pole always exist in pairs, and even in the smallest piece of the magnet, even if we break the magnet, okay, what will happen again, there you will see there appears north and south pole, all right. So a single north pole or south pole cannot be exist. So the question of this answer is no. Okay, I hope you have understood. So now let us see how can we find direction using a magnet. So for this also we have an activity here, okay. We'll do the activity first and we'll understand. So finding directions. Activity 4.3, let us experiment. Suspend a bar magnet with a thread tied to the middle of a magnet as shown in the figure 4.5. You may need to adjust the position of the string till the magnet is balanced horizontally. So like this, you can keep a book here, okay, and you can tie this bar magnet using a thread over here, okay, and you have to keep it horizontally, means like this, okay. Vertically is like this and horizontal is like this, okay. So here we are going to put this horizontally, okay. Now rotate the magnet gently in the horizontal direction and let it come to rest. So now rotate this magnet gently, okay, and let it come to rest. And after that, mark the position of the corresponding to the ends of the magnet on the ground or on a piece of paper. You can either mark these ends of the magnet, okay, like whether it's north, south, east or west, okay, in the piece of paper or in the ground. So now again, join these 2 points on the ground with a line. So you join these 2 points, okay, with the ground on the line, and this line indicates the direction along which the magnet comes to rest, okay. So we'll join the north south direction and eastward direction, and we'll see in which direction this magnet will come to rest. Like this, we'll just make a diagram here like this, okay, in this paper. So this is the north, this is the south, this is the west, and this is the east, okay, like that. So now again rotate the magnet by giving a gentle push at one end and wait till it come to rest again, okay. Now what you have to do, you have to rotate the magnet, okay, and give a gentle push again on the one end, and let us wait until it come to rest. So thus the magnet rests along the same line. So yes, and in which line? That is in the north south direction. And why? We'll learn the reason, okay, why a magnet always rests on the north and south direction. The reason we will learn here in this book, okay, in this chapter. So again, here some questions are here and some information is also given. First, let us see, okay, which direction does this line indicates along which the magnet rests? How can we find it out? So the direction is the north direction, and how can we find it out? We'll learn about that. So if we have noticed the direction of the sun rises or sets, we have an approximate idea of where east or west is. See, when we have an approximate idea from which direction the sun is rising and from which direction the sun is setting, we had approximately the idea of direction. If we know the east or the west, we came to know the north or the south also, isn't it? So hence we can locate the direction along with the magnet's rest, okay. So here we can locate the direction using the magnet. And how? Let us see. So this was a freely suspended magnet bar, isn't it? So a freely suspended magnet comes to rest along the north south direction. This is important, okay, and please remember this one. It always rests along north south direction. It will never rest in the east or west direction, okay. It will be always on the north south direction. The end of the magnet that points towards north direction is called the north seeking pole or the north pole simply, okay, of the magnet. And the other end that points towards the south direction is called the south seeking pole or the north pole, or the south pole of the magnet. So the direction of the magnet which is towards the north it is known as north seeking pole or the north pole of the magnet, or the direction which is towards the south direction is called the south seeking dipole or the south pole in simple language. Okay, so a freely suspended magnet rests along the north south direction because our earth itself behaves like a giant magnet. See, our earth have so many magnetic properties with it. Okay, so that is the reason why we have this magnet always rest on the north south direction. And about this earth's magnetic field and all these properties you will learn more on in your higher classes. Okay, as for now, what you need to understand, you need to understand that the magnet will always rest on the north south direction because of the magnetic properties of the earth. Okay, so earth also, because earth also behaves like a giant magnet. Our earth, giant means very big, isn't it? So it behaves like a very giant magnet, and because of that property, this magnet always rests on the north and south direction. All right, so repeat this activity again. We'll repeat that same activity, okay, with small iron bar. Now in place of this magnet bar, we'll take iron bar, okay, in place of the bar magnet. So what do you observe? What will observe? Does it always rest along north south direction? It does not. It will not rest along north south direction. It can rest in any direction. Why? Because the iron bar doesn't have magnetic, isn't it? It is not a magnet. So this implies that only magnet rests along north south direction. So we have also proved now, okay, that magnet always rests on the north south direction. So this activity provides us with a way to test whether a piece of metal is a magnet or not. So through this activity, what we can also know, we can also test that whether a piece of metal is magnet or not. If it is metal, it will attract towards the magnet. If it is not metal, it will not attract towards the magnet, as we have done with some of the objects earlier in our table, isn't it? And we have filled the table also. So now let us see. The property of a freely suspended magnet to always rest along the north south direction is used to find direction. So because of this, see, this freely suspended magnet, okay, they always tends to rest on the north south direction, because of which we are able to find the direction. Okay, we are able to find the direction, because if we know the north south direction, easily we can know the east and west direction also. See, this is a magnetic compass here. Okay, so based on this, okay, small device called magnetic compass was developed in olden days for finding direction. So based on this concept that magnet always race towards north south direction, a small magnetic compass was been developed as shown in this figure. All right, it has magnet in the shape of a needle which can be rotate freely. So they have this one, okay, this one, needles, and this rotates freely, and the needles of a magnetic compass indicates the north south direction. This indicates the side north direction, this outside direction, and the north direction is always painted with red color. Okay, the information is given in your book as well. So the compass is kept at the place where we wish to know the direction. It will be given to the place where we wish to know the direction. Okay, see, in your phone these days what happened, we have this compass and easily we can know which direction we are sitting and which direction is the other one, isn't it? So in the case of ship, in the olden days especially, how they will find a direction, isn't it? So using this, they used to find a direction. After some time, the needle comes to rest to the north south direction. The compass box is then gently rotated until the north or south mark of the dial are aligned with the needle. So after some time, what will happen, this needle will come to rest on the north south direction. Again the compass will be gently rotated until the north south direction are been aligned with each other. Okay, like this aligned. Okay, so now all the direction at the place are as an indicated on the dial. So all the direction are being indicated on a dial as well. See, it is just like a clock, isn't it, where everything has been written. So the direction, the degree, everything is written here. Okay, so let us see more about this magnetic compass, more information about this magnetic compass. A magnetic compass is usually a small circular box with a transparent cover on it, as shown in the figure 4.6. The magnet in the shape of a needle is mounted on a pin standing on the bottom of the box. Okay, the magnet is in the shape of a needle there. Okay, and it is standing on the bottom of the box, and this needle is balanced on a pin in such a manner that it can move around these point easily, that is, it can rotate freely. So this needle is placed in such a way that it can rotate freely and it can choose the direction there. Okay, the end of the needle which rests in the north direction is usually painted red, as I have already shown you above in the figure. Okay, and below the needle there is a dial which with the direction marked on it. So below the needle you'll find there are other direction which are been marked on it. They, like we have here north direction, here south direction is here, southeast direction is here, isn't it, east direction. So all the direction are been marked. so that it will be easily done. So now we have another activity. Okay, before this activity there is a question which has been raised by this girl. Okay, how can we make our own magnetic compass? So can we make our own magnetic compass? Yes. Okay, so how? We'll find out through this activity. Collect a few materials like cork piece, iron sewing needle, and permanent bar magnet, and glass ball, and a water. Okay, you need these things in order to conduct this activity. Okay, so now what we have to do: place the iron sewing needle on a wooden table, then keep any one pole of the magnet at one end of the needle. Move the magnet over the needle along its length as shown in figure 4.7a. When it reaches the other end of the needle, lift it up. So like this, you have to keep this needle on a table, okay, and in one end, starting from one end, okay, from one end of the magnet bar. All right, so you will be moving towards the needle like this. You will be going towards this, and when you reach here, you have to lift your hand again. You have to go in this motion. So you have to do this movement for 30 to 40 times again and again. Okay, so bring the same pole of the magnet you started with the same end of the sewing needle from which you began, and repeat the previous step. Repeat this process at least 30-40 times. So you have to repeat this process for 30-40 times. All right, and next, bring some iron fillings or steel pins near the needle. If the pins or iron fillings get attracted to the needle, then it means the needle has become a magnet. So see what happens now: bring some iron fillings or some steel pins, okay, and if these iron fillings or steel pins are attracted to the needle, that means you have just made the needle a magnet by moving the magnet again and again, okay, within it 30 to 40 times. So this is exciting, isn't it? So in this, what you have done, you have made the needle magnet, isn't it? So with that needle, what we are going to do, we are going to make our compass, okay, magnetic compass. So pass this needle through the cork horizontally on or any light thing, okay, and float the cork in a glass bowl filled with water such that the needle always remain above the level of the water as shown in the figure 4.7b here. You can pass the needle in this cork, and you have to place water in this glass bowl, okay, fill this bowl with water, and you have to place this cork, and what happened again, you have to keep in mind that needle should be above the level of the water, just like in the image, okay. So now what happens? When the needle comes to rest, your magnetic compass is ready for use. So this is very exciting, isn't it? We have just made a compass needle in a bowl of water. So note the direction in the which either side the needle points. So it will point always in the north-south direction, okay. So rotate the cork gently again, watch till it stop rotating. Repeat it a few more times. Do the ends of the needle always point in the same direction? Yes, it will always point in the same direction, as this needle will have also become magnet. So what we have done, we have just made a compass needle in a bowl of water. So there are some exciting facts again here, okay. Much before the widespread use of the modern magnetic compass. So in today's day we have so many modern magnetic compass, isn't it? But much before that, okay, a device similar to the compass needle made by you, which has been we have made by using water, needle and cork, isn't it? So was used by the Indian for navigation at the sea. So it was being used by the Indians to navigate the sea, okay, to see the direction. So it consists of a magnetized fish shaped iron piece kept in a vessel of oil. So just like that needle, okay, they have a fish shaped iron piece, okay, and what happened, they kept in a vessel full of oil, okay, vessel of oil, and it was called Matsya Yantra or Machu Yantra. Yantra means device, okay. So this is a fact that you need to know, because before the invention of this magnetic compass, Indians already find the way how to navigate in the sea. All right, so again there is another question here. What happens when we bring two magnets closer to others? So again this girl is raising another question that which we will learn in our next topic, that is attraction and repulsion between magnets. So we will do this in our next class. As for now, we will stop here. I hope you have understood, and if you liked my video, don't forget to hit the like button, subscribe my channel and share with your friends as well. So all of you have a very nice day ahead. Bye.